Hello, everyone. My name is Mary Grogleski. I'm a developer advocate at IBM and very glad to be at EclipseCon 2020. My topic today is on deploying a modern serverless container as powered by Vertex. But actually, a lot of the things that I'm going to be talking about today will be on the reactive side of things. So. All right, let me progress. And I know I only have 30 minutes, so I'm going to be a little bit maybe brief too. So first of all, too, let's why Vertex, right? Vertex is as such Eclipse Foundation project. And as I found out too, because previously when I first started doing Reactive, I was working mostly like at IBM with the Lightband platform. But as it turns out, right now too, it's, I choose Vertex because it is very lightweight, is reactive in nature, event-driven, and is the asynchronous engine that powers Quarkus. And I know one of my colleagues too talk about Quarkus, and some other speakers here also talk about Quarkus. And as such too, that's the engine behind it. And as such too, there are also libraries such as like Mutiny, that's actually the one that now is like power it too. And lightweight, and it was relatively simple toolkit. I wouldn't say it's all simple, but it's actually sounds simple, but it's not. Very flexible. And another strength of it is that it's a polyglot nature of it. And it's very interoperable. The idea is that the opportunities are unlimited. And basically too, today I'm also kind of bringing in the, how do you kind of do deployment to the cloud part. So it's all serverless, ready, like that. So very modernized. And let me then progress. And again, when I kind of talk about Quarkus and Vertex, the thing is that in Quarkus, you cannot see Vertex because it's the layer that's kind of underneath. It's like when you go on the street, plumbing, you cannot see the pipes and all that stuff that's working, but that's what is happening. Vertex is working underneath the hood. So yeah, if you look into here, so basically it's the application that goes into the routing layer, and basically to the routing layer then goes through Vertex. Its event bus is really powerful and kind of eliminate the need for a user, an application developer, to deal with threads directly. And so basically it's the Vertex that's handling request and response. So before I actually get a bit deeper into like Vertex, because this is a more beginner talk, I'd like to kind of talk a bit too about reactive Java and just kind of get everybody on the same page. So bear with me if you're already familiar with it. When we talk about reactive systems, we cannot avoid saying reactive manifesto. Now, again, it's reactive. There's actually the fine line between the reactive systems and then the reactive programming part, as well as the reactive streams, the specification. So reactive manifesto is essentially there are 4 core tenets, which is responsive. Responsive, and meaning that requests going into a system, they need to be handled in a very timely manner. That's being very responsive in a nutshell. So that's being enabled to essentially too in today's world, in the cloud infrastructure. It's basically a lot of the performance is improvement, their clustering. So all of these other things. So if you look, let's look into the left side, the elasticity meaning that, yeah, if there are a lot of requests coming in, then the system needs to be able to handle it and be very, kind of like flexible, elastic, more processors, more processes, or whatever is needed to process your requests. Let's say I like to use, like Valentine's Day for a flower shop, online flower ordering. So on Valentine's Day before that, you get a lot of orders. All of a sudden, your system is flooded. So the system, in order to be qualified for reactive, you need to have, many processes being able to handle all the load. And then when it's like, slow time in the summer, you get flowers outside and there's no need to be working with that, then you don't need as many processor. So it's kind of like returning all the resources back to the pool. So it's, in other words, very scalable, very elastic. So that's another characteristics. And then if you look into the right side, there's resiliency. meaning that even, in any error condition too, the system should not slow down. So the responsiveness should be maintained. So then the system needs to have some mechanism of handling kind of the problem with it, and then being able to bounce back pretty quickly. So that's also error handling needs to be very responsive as well. And then all these three, I always look at then the fourth thing in here, I call it fourth thing, is really the message-driven mechanism that is enabling all of it. And by being reactive, your system has to be very loosely coupled. Nothing is kind of like tied together. But the amazing thing is that even though we call it like loosely coupled and message-driven, they all do their own thing, but the whole system as a whole, they need to be all kind of working in a very coherent fashion. And message-driven as such too is essentially messages passing between different endpoints like that, and which is different than event-driven too, because event-driven is a bit more like your messages are being emitted by a source, and the source, it doesn't know where the messages are going to, and it's really up to the client who's interested in the messages will kind of subscribe to it, for example, in a reactive extension kind of manner. So. Okay, so here just kind of a quick thing too to give you some also a bit of broader understanding how Vertex fit into this larger picture. These are like some of the reactive popular reactive toolkits and libraries, open source, that are kind of popular in today's ecosystem. So of course, first and foremost, we have our microprofile too, and that's actually a library that's more catered more for building like microservices. And I'm sure, a lot of our colleagues and fellow folks, in the microprofile community working group are working on it. That supports also reactive streams, and through them reactive, the messaging and operators, they handle that. And also too, then there's reactive extension in here, the RX Java, of which like Vertex has also like very good integration with. And I have some example that I'm going to be showing you too in this talk later. And so that's, basically, yeah. So, okay, then there's also then Akka, and Akka, it's basically from Lightband, and that's also a very highly reactive. In fact, Lightband is the one that leads they establish or help to define the reactive manifesto, and their kind of very sophisticated framework library, making use of the actor model. And it's a pretty unique kind of modeling that's actually based on Erlang. It's not really all new, but this isn't to talk about it, so I won't go into details. And there's also Lagom, which is a microservices framework, that's a library that's built on top of Akka. And then the Play is their front-end processing, their more user interface part that's also built on top of Akka. And then there's also, without, how can we go without Spring, in Java? So that's the Project Reactor is essentially the reactive library that's kind of powered the Spring Web MVC, or actually I should say Spring Web Flux kind of web framework too. So that's Reactor, which actually their operators too are essentially interoperable with RX Java, because the engineering team they're both the same working on it. So. And this is also a quick thing too about like reactive streams too. There's also our socket, which is actually now managed by the Reactive Foundation underneath the Linux Foundation. These are the 6 companies that started it. And of course, VMware, actually, this is a bit of an older slide from last year. And so VMware is the one that provided this slide. I thought it's kind of nice because I wanted to point out, because our socket is a bit of a lower level layer 5 and 6 communication protocol that's also based on reactive streams and is really fast too. So just to give you some kind of a comparison. Okay, so now then let me kind of I'm keeping track of the time. So getting a bit then into Vertex, right? So when we do Vertex, we work with the core library, and some good examples of use cases is like a list of all of these things, but I want to highlight, it has this event bus that is very powerful. And the thing is too, is that it's also quite simple to use. For example, like in terms of showing you like setting a periodic delayed action kind of call is basically set periodic, and that's how you do it. And you can also, you can also like doing deploying and undeploying the verticals. Vertical is the model that's being or supported by Vertex, and I'll go into that shortly, but it's not enforced. You don't need to use it, but it's highly recommended because it provides like a unit of deployment, especially say in today's like cloud infrastructure. It actually makes sense to extend your abstract vertical, or you can write your own too. So, okay, so these are again some of these examples to use Vertex. And some usage and dependency on this is you can like build just like anything. This is dependency for the core library. Currently, they're up to 392. And then Gradle too is you can just do compile and then give this directive. And in Vertex too, actually, the kind of very basic of it, and that's why I like it too, is that it's simple. It's all you need to do in your runtime is essentially just start up the object Vertex object control center. So by doing a vertex.vertex, and we'll have some examples too. So this is like runtime options. How you do it is to add an option. You can pass in the instantiate your Vertex options and basically then do a set, in this case, setting a worker pool size of 40. So you can also then have other options as well. You can find out from the documentation. So again, Vertex is very event-driven. Some of the example events will be like a timer has fired, or data has arrived on the socket, or data have been read from disk, an exception has occurred, or HTTP has received a request. These are just kind of pretty common examples. And in event handling, for example, like you want to receive a timer event every second. So I mentioned about all you need to do will be do the Vertex set periodic. And in this case, is passing it like 1000 millisecond is like essentially every second. And then using a Lambda expression. And basically, I'm just printing out this timer fired. And of course, you can use your favorite logger too in real production system. And then you can receive an HTTP request. Now, every time with Vertex too, we make use of like a handler to handle any kind of processing. So in this case, like for HTTP server, you want to do a request handler. In this case, it's basically using a Lambda and then doing this chain style, we just print out hello world. Okay, and again, I mentioned about the vertical. So vertical is similar to the actor model in akka, and it's not a requirement. It's a unit of deployment in Vertex. And a vertical processes incoming events over their event loop. An example of some of these events, which I mentioned about timing events, network buffers, messages sent by other verticals. And event loop, a bit more about it. Event loops are typically used in asynchronous programming models, and each event gets processed in a very reasonable amount of time. So then you're not blocking the event loop. And every event loop too is attached to a thread. And by default, the Vertex attaches like 2 event loops per CPU core thread. Okay. And some words too about event loop and vertical. A regular vertical always processes events on the same thread. And so that's a nice thing too. You use a reactive library. And I actually got asked this question, like people are saying, well, why reactive? Why is it so? The thing is that before all of these reactive, kind of a new wave of reactive revolution, basically everything was simpler, life was simpler, but then not as powerful, is that when we deal with like trying to do multitasking, then we have to deal with threads ourselves. So all of these threads, it happens in the kernel. So can you imagine then that's why things are not as fast, because then every time you have IO, you're holding up that thread. But now with reactive is that you basically still have threads, but they got moved into user space. And so, but in this case, to Vertex is make use of the event bus, and so it handles all of the thread coordination. So then, as an application developer, we don't need to deal with these like lower level kind of concern. And a vertical can be passed some configuration like credentials, network addresses, all of these configuration, and can be deployed like multiple times, and you can deploy other verticals as well. So here's a picture of that. So like this is an example of a configuration coming to the vertical. And the vertical gets deployed and deployed like multiple times. And so basically network events will come from the acceptor threads. And also too, the highlight of Vertex is that it's very polyglot in nature. It supports like multiple languages. All of these are listed here. And I think the Python enclosure apparently will be in earlier version, although maybe Python is already like ready in 3.9.2, but it doesn't force the usage of any languages. That's the beauty of it. And so basically, and that's my thinking is that, in terms of, some practical usage, how can we address, problems in today's climate, right, or world? And so we can actually think of ways of like wrapping some legacy kind of components to kind of using a reactive pipeline and build up like truly like a hybrid pipeline, making up of different libraries and making it really functional too. So anyway, that's just some thinking about, kind of what can we make use of, a library such as this, make it even more like powerful in that sense. So. Okay, so here's an example too, which I'll show quickly, is that it's just illustrate, right, this polyglot nature. I have a simple case in which I'm basically sending HTTP requests, and I'm writing a vertical, I call it like an API kind of gateway that funnels the requests. And then I have different worker verticles that handles, they're written in different flavor, Java, Kotlin, and JavaScript. And basically is the event bus would take care of kind of, doing all the work and doing the work and then telling each of the vertical to do their work accordingly, based on the request. So the JavaScript side is basically have a sock.js bridge over it. So I'll be showing that shortly. I think I only have about 10 minutes or so. So it gets into some example, but okay. So these are just some of the kind of state transition diagram, but I will quickly show you. Okay, so now I'll get into that part later, but I'm feeling a bit rushed, so I'm sorry, kind of looking at the time. So, okay, so I was kind of talking about this. Well, let's first look into a simple case. So this is like any kind of demonstration, right? We want to show something kind of more basic. So in this case is a hello world, hello vertical. So I extend abstract vertical. And so that's why I kind of like about it, because it's a bit kind of simpler. All you need to do is extending it, and it's basically implement your functionality from the start, and then you can kind of handle the rest of the thing. So over here, Vertex set periodic. In this case, I showed it earlier. So that's how you set a timer, and then also like set the create a HTTP server listener. In this case, I have I'm using this Lambda expression, and basically too, it's I'm setting the request handler, and then also binds it to port 8080 in this case. So in order to start this, again, earlier I showed the control center. You start off the control center, and then all you need to do is doing a deploy vertical, and then basically then instantiate. So over here, and that's how you deploy the vertical. So all these are not cloud yet, and which I'll bring up shortly. So I'm not going to have time to run it, but let me then quickly show the API vertical that I was showing earlier. So over here too, I extend abstract vertical, and basically too in my start, right? I talked about a configuration. So over here too, I basically am making use of the config retriever to handle this. So over here, I read from a property file of my config.json. So over here, just a quick simple thing, and just have port and then delay and work account, some simple configuration data. Go back here. And so, I'm making use of the config store option, and then do the retriever, and then basically then add this file store, and then basically too, the nice thing is you can actually have the retriever listen for any changes, and so then you don't need to do these get kind of like handling of updating your runtime configuration parameters. So okay, so that's the configuration part, and then here here it is too. I'll show you. Is in over here. Well, okay. So from the start part, if everything is good, then I process my configuration, and I also then set up my router. Over here, for example, router, I have separate handler to handle different things, and I'm handling the cores, for like any kind of web apps. And these are my router. I set up the different call, and then and then sending them to the different methods that will have processing to handle it. So. And again, this part is basically the sock.js bridge that I talk about, and this part is for handling the JavaScript. But as such too, right now I'm still in the process of kind of working on this, and basically it's my Twitch stream that I'm showing this. So If you're interested to follow me on my Twitch, which I have some information about. So, okay, so let me then quickly look at it. So all of these methods are different, kind of ways of handling all the requests in here. But I wanted to quickly show is the how I do the deployment. So over here, right, I talk about, I can deploy my Java, some worker vertical to do stuff. That's my Java. So all we will need to do, okay, all these setup of configuration. Then again, this is the line that I basically can then deploy my vertical. And this is actually the Java worker vertical class. And that's how I do it. And that's all I would need to do. But of course, then I have to handle some of these other things like, the deploy vertical has this variations of you also handle any kind of error, or if it's good, you go ahead and actually deploy vertical. In this case, in this example, I'm actually measuring, doing some metrics too. And over here too, like if it's Kotlin, then all I need to do is basically deploy vertical, give it the Kotlin vertical class.getName. And same thing, and for JavaScript, all we need to do deploy vertical and give the JavaScript file name, the interface name. So the interface to the JavaScript. So that's how essentially it handles this. But we'll take a quick look then in my Java worker vertical. So worker vertical essentially also do the same thing. It extends abstract vertical. And then over here, then it does what it is going to need to do. In this case, I'm also reading the configuration and all of these things. And basically, in this particular case, too, as an example, I'm not doing so much, but in reality, you want to implement whatever business functionality you have. So, okay, so this is kind of the example. And now let me go quickly then get more into the, back to my, let's see, I'm so sorry. Let me kind of go back here. And talking about the building part, and which is, okay, let me quickly. So just quickly getting into the building, the deployment part to the cloud. I actually have a workshop too, so I'm kind of come well prepared. And so to kind of invite you to join my workshop, it's actually going to be next Monday too. But I want to quickly kind of point out to deploy this as especially in kind of a more simple case, and I can just quickly show you kind of the steps. And it's actually surprisingly not too complicated. But once you set up, right, if you need to set up your Kubernetes, you need to set up, in this case, I'm using a Knative for the serverless deployment. So of course, there are all of these steps too. And I've also done it on Google Cloud as well, in addition to IBM Cloud. So it's pretty much, when you get to Kubernetes, it's nice because it runs on all clouds. So it's essentially a kube control. That's how you do it. But first of all, serverless deployment, without going into all the details, we're talking about scalable applications in a modern dynamic environments. These are the cloud environments, can be public, private, and hybrid. And then serverless deployment, the application techniques would be containers, microservices, serverless functions, immutable infrastructure, all of these things for serverless. That's the whole point. And Vertex is kind of set itself up really nicely. So, okay, so in order to kind of build and deploy, all we need to do will be, it's actually, in this case, I'm still using Docker. So and there are other containers you can use too, but essentially do a Docker build. And then over here too, and I would obviously need my Docker Hub too. And basically I build and then have my particular, in this case, a hello world. And I basically build my image and basically push it to my Docker Hub. Then all we'll need to do is actually with the Knative, and you would be able to then do a kube control and apply a file name, which is like my service YAML. So, okay, I'm kind of sorry. And let me kind of take a look. I think I need to bring this up. Okay. Okay, I just see some, I just want to make sure that I'm not like, kind of running all of kind of no time. So, okay, so this is just how you can kind of quickly do it. So it's kind of nice too, because I did it on Google Cloud and then it's essentially the same step, for a very simple type of scenario. So, okay, let me then kind of, oops. Okay, so I know that I only probably have like a minute or so left. So let me quickly kind of go over this workshop next Monday at 8 a.m. Pacific time. If you want to interested, scan this IBM Cloud Chicago. There are multiple ways. There's San Francisco City team that will be hosting me. So that's a Monday. We'll get more into details. You'll get 48 hours use of a Kubernetes OpenShift on IBM Cloud. And then, okay, sorry. And then there's also, I have also a live stream on Twitch too, every Wednesday. It's around like Wednesday, 12:30 Central Time. And this is the link to join the IBM developer on Twitch. And I'll be there every week. Rain or shine, I will be there. I also want to invite you to join my Discord server if you're interested in continuing the conversation. I mean, as such, I feel kind of like a whole bunch of stuff I'm talking kind of really, really fast without even thinking in such a short time. So there's actually plenty of conversation. We can talk about it the whole year, everything. And you want to join, please join me on my Discord. You're interested? And here, and then I want to thank you, and it looks like my time is far up. And so this is the link to get more information about the IBM developer for reactive systems. And IBM doesn't actively maintain the Vertex, but it's our Red Hat brothers and sisters over at Red Hat that's doing it. So, but then we work closely with them. And of course, Quarkus too are participating in that. And this is our IBM Cloud free tier if you would like to get you know, a free copy of it. So yeah, so okay, cool. And I think I believe I should be getting some questions, and I will try to answer. I'm sorry. Let me kind of go back now. Okay, so I got one question. Can Vertex work without Netty? Yes, it doesn't have to be with Netty too. How does it compare to something like Kafka? Kafka, okay, so Kafka is obviously, yeah, that's also a stream, and I actually have not worked with that yet, but there are definitely like support in any kind of reactive library and also Vertex too. And how do you compare with it? I think they solve problems on like different levels. Kafka has is much like you have topics that you need to subscribe to, for example. So it's kind of, it works a bit kind of differently in that case, but I'll be interested to talk more on the chat afterwards. And let me see. And okay, can Vertex support operator for cloud deployment? Yes, and it actually does. But again, we will talk more. And in fact, all I was showing was only, by the way, it's only Knative serving. So that's the part that handles deploying. A lot of things I didn't even touch would be like the versioning, things like that. There's also a Knative eventing part, which I would also like to be talking about. But well, you brought up operator, so I thought I'd bring this up as well. So, okay. Does Vertex support operator? Oh, okay. So I think I already answered it. So yes, it supports that. But let's kind of go a bit further. Maybe in the chat we'll talk something more too. That part I have not kind of got more into that. So okay, and let's see. I think maybe I'm almost like 1 minute. Let me kind of make sure. Okay, I think it looks like I have answered all of the questions right now, although I have to admit I'm not, you know, kind of very detailed, but let's follow me on my Discord or over here too. Then, yeah, thank you. Thank you, Emily. Thank you so much. And thank you, everybody. I know it's kind of a bit of a rush, but I hope you can join me at my workshop next Monday if you want to, and then you get more hands-on and we have more interaction. There's an hour and a half. So awesome. Thank you so much and have a great day. Thank you.